Okay, I guess this is a midterm exam week, right? So many of you are absent. How are you all doing with the project? Okay, doing okay? You're finishing up?
Yeah.
Okay, good. Yeah. I think we'll have a shorter class today for about 30 minutes to cover the first part, like the simple linear regression. And then we'll leave the rest of the time for you to ask questions about the project and to work on your midterm exams. So starting today, we will talk about machine learning algorithms, which in the data analytics pipeline is also called data prediction. So the definition of machine learning, which was created in the 1960s. So basically, it is for the machine to learn from the existing data and then find a pattern, to apply the pattern to predict it. Yes.
Pardon our sudden intrusion. We are part of CS 1301, and our professor is absent today. Do you know if he had sent out a some sort of like letter saying if like there's a substitute teacher for the class? He's Bruce Bumster.
I'm not aware of that. Would you go upstairs to the CMC department to ask them? You can ask Ms. Jane or Ms. Anne. Okay.
I'm very sorry. Oh yes, I do know where they're at. I'm very sorry about this.
Is this the exam?
I don't know if this is Okay, thank you very much. I'm very sorry about this. Yeah,
It's for the machine to learn the pattern from the existing data and then predicting the future data. There are a couple types of machine learning. One is the supervised and unsupervised. These first two types is distinguished whether you have a target variable or not. So for example, I have a bunch of apples. I know, maybe I have a bunch of watermelons. I know one variable seeds, and if I have a variable whether it has seeds or not, and then the target variable is what type of watermelon it is, and so the target variable is very clear: a seedless watermelon or seeded watermelon. So there's a target variable. However, if I have a group of watermelon and I don't know how to categorize them, there's no target variable. I need to categorize them into sweet or unsweet, seedless or unseedless. Then this is an unsupervised learning. So the distinguisher between these types is whether it has a target variable or not. And reinforcement learning. This is more complicated. This is used for more of like artificial intelligence, like the robotic chess player or your self-driving car. These use this reinforcement learning. So the machine, the algorithm need to continue to learn during the process. And before we further divide these types into more details, we have to learn features and labels. And these are called the one is the target variable. So this is the seedless non-seedless watermelon. We know we want to categorize into, and then these are the independent variables. For example, the size of the watermelon and whether it has seed or not. This is obvious, correlated with the categories. Or some other variables like sweet or not, unsweet. So these are called independent variables. Also called features. And this is called a label, dependent variable. So this target variable is depending on these variables. And the features are also sometimes called explanatory variables. And depending on this target variable is numerical value or not, we categorize the supervised learning into regression and classification. So, for example, if the target variable, what we want to predict is a numeric value like weight or like the length of a tree, then it's a regression. And if the target variable is a categorical value, like seedless or non-seedless, where watermelon or different apples, then this is a categorical target variable, and this is called a classification. And then the supervised learning, we have classification and association. So in this class, we'll learn regression and we'll learn classification. Depends on the categorical variable. It has only 2 categories, or it has multiple categories under the target variable. And we'll also learn clustering. These are basic machine learning models. If you would like to explore further, I believe our department offer higher level classes like machine learning or some other classes. And also, I think more important is this class give you a good foundation, like how to clean the data, process the data to get ready for the machine learning. And for applying these models, you can further learn and then use these techniques to just apply the model to the data. And it's really for all these models, the algorithms, the package in Python, they already designed everything for us and designed the algorithm for us. We only need to understand the algorithm and then apply the algorithm for the data. So linear regression, it's simple enough. We want to predict A based on X. So for example, here, it's a group of people's height and weights. A couple dots here. So what we want to predict the weight according to the person's height. And what we want to generate is create with the linear regression. We want to get the line y equals x a plus the bx, right? So how can we do this? here, I just need to add a, no, just need it. Okay, I can use this one. So we want to find this line. Y equals ax plus b, ax plus b. So you can draw many lines. How can we find the line that best fits this these dots? You can change this line to here, to here, or a little bit over here. So how can we find the best line fits these dots? So this algorithm find the best line by calculating the distance from the prediction line to the dots. What line should fit best? The distance of all these dots. The sum of the distance of all these dots is the smallest. Then this line is the best line, fits with the dots, fits the dots. So that basically what this algorithm does. And really for writing the code to find this line, it's quite easy. So what we need to do, first I generated this data here and plotted it on a scatter plot. And next, we just get the package and then apply this package on the data. So the package we are going to learn is called this skylearn.linear model import linear regression. Okay. After import this linear regression, we are able to use the method. For example, I build a model equals linear regression. So this is a model I'm going to use. And then I'll use this model to train the data. So give this existing data to train this model. Okay. That's the height and weight. And really, that's all it does. So now we've already built this linear regression model, and now we can predict a new data. For example, I want to predict height is 80. So model 2 predict. Okay, this gives me an error. We have to be careful when you give the data to the model. When you either training the model or predict the model, we have to be careful. This data has to be a 2D array. So here, this data I need to give it to should be 2D array. So I need to add some squares to make it a 2D array. Now it gives me the result. A person who's 1.8 kilometers should be like 80 at around 80 here. Okay, so so this is a 2D array. This is why it's not a. This is a 2D array. So if I want to predict a series of data, a couple of people's heights, what should I do? I need to add a couple add a couple of 1D array inside this 2D array. Okay. I cannot explain why it's designed this way, but you have to give it a 2D array. And if you got a 1D array like this, if the data you got is like this, a 1D array, you can use a reshape like this. Okay, if you got the data like this format, it's a 1D array, right? Then you have to use a reshape to change it to a 2D array. Okay, so this is what we have to be careful when we use this model. So I predicted this new data, and next we can use this to predict to generate this line. So we used these we generated this scatter plots already. What we need to add is just to add a line plots, right? Add a line plots. What we said add a line plots is to just add a line here, plot, and the same height, but instead of the actual weights on the prediction line, we use the data with the predicted weights, right? So how can we write this one? It's not the actual rate. So the prediction line is the prediction line is the x is the actual x, and then the y should be the predicted y. And how can we write the predicted y? We just used the code here. How can we write this? We copy this code and give it to the what should I write here? Predict what group? Predict the yes, we are predicting the weight. So here I predict some individual height with the height number, individual height. So here I give it what parameter should I give?
The height.
Yeah, the height. Yeah, actual height. So here we should get the actual height and then the line, the predicted line here. And so we mentioned finding the best line is to find the line that has the smallest distance to all the dots. The sum of the distance to all these dots is the smallest. So how can we evaluate whether this line is good or not? Let me draw another example, okay? Oh, this is an example we just had with the height and weight, and it's found the best line. And probably more likely we get a graph like this. This line, I find the best line, but this model, it's not as good as this model. Well, it has a it has the distance to the line is wrong. Give me I'll give an example. So if we only evaluate this line by the sum of the distance to this line, what will be the problem? Here, for example, this in another case, I have more instances in this data set. Then the sum of the distance will be very large, right? But this line is a very good model to this data. So what they used another variable to evaluate the line is to calculate the distance to the what is it? The calculate the distance to the this is the I believe it's the y mean of y. Calculate the distance to this y and then divide this all the sum to the prediction line. Divide the sum to the prediction line this distance and divide the sum of the distance to all the prediction line and divided by the sum of the distance to this mean. And here we get a relative number here. So this RSS is the sum of the distance we just used. Okay, it's the distance to this prediction line and it sums up. And then this TSS is the dots, the distance to the y mean. And now, so this is the relative number, and it's 1 minus this number. So the largest value this can go is 100%. For example, let's think if this all these lines fit in this perfectly. This line fits perfectly on the dots, and then this RXX will be 0, and then this is 0. So that then this is 0, and this R squared is 1. So when the R squared goes to 1, it means that the line fits perfectly to the dots. And when it goes to 0, and that means that it doesn't fit the dots perfectly. So this is the R squared. It's usually used to measure the model, whether the model fits the data or not. Okay, and how do we get the R squared? So it's just a model and a score, and we use the heights and the weights. Model 2, right? Model 2, and then it will give us the R squared value. Okay. Usually, this is the training data. So training data means that the data we used to generate this prediction model. If it's a training data, then this R-squared score is usually higher. But if for these data, you use the testing data. For example, if we have a testing data set, and then usually this R-squared score is smaller than the one from the training data set. Next question is, how can we know the y equals ax plus b? Can we know the a and b now and generate the formula now? Yeah. Oh, we should be able to know all these parameters, right? So how can we get to? We could use this method to get to the intercept and the coefficient. So that's the intercept. It gives you an area. And also we can get to the coefficient. So I must remember the wrong. Okay, so please watch here that the coefficient, they give you it will return a 2D array, and the intercept, it gives you a 1D array. So if you want to just get this data, you have to use the index 0, 0, 0. This one is just a 0. Okay. And another thing we want to be careful when we use this linear regression model is when it has an outlier. We have an outlier. For example, here we have a dot here. This will drift the line significantly. Right? So you got the data here. When you add data here, added a data here. So if you just evaluate if you just filter the outliers by the weight, it probably didn't filter out this one. If it's close, like not very far away, right? Like some dots here. So when you filter just by the height, it may not be filtered out. These are further. These heights are further from the normal range. So these may be filtered out, but these may not be filtered out. However, they will dramatically shift the line to this direction, right? And make the prediction line not accurate. Because they calculate the sum of the smallest distance, and to compromise these, the line has to drift the side. So we have to remove these. You have to be careful of these outliers. and filter out these outliers. We call these outliers, and these we call extreme values. These extreme values, will they affect the line? These extreme values, they will not affect the line, but they are on the direction of the line, and the line still goes to this direction. But the outliers, although they are not large weights on not large heights, so they're within the normal range, but they are outliers and they affect the prediction line, the accuracy of the prediction. So yeah, you have to plot the scatter plots first and then take care of the outliers. Okay. So in this week's assignments, you will be asked these questions as well. Next, on Wednesday, we'll further talk about multiple regression. For example, here we only have one X variable, but in most cases we have multiple X variables. We want to predict the house price based on living room, square living room, and the status of the house, how many floors the house has. So it has multiple variables, and also if the line doesn't exactly follow a linear regression line, instead a curved line, the dots are curved, scattered curved, then we use a polynomial regression. I mean, which means that y equals ax squared ax squared plus bx plus c. Right? So on Wednesday we'll introduce these models. Okay. So we'll leave the rest of the class to check the project one and to